Hi everyone, welcome to Become the Tube. In this series we are taking a look at the neural network to read the MNIST database, the handwritten database, in both C++ and Python. In this video we are going to download the data. If we download from the official website, the MNIST.gov, the database has 240,000 images, but the C++ PyTorch, the Libtorch, has hard-coded to load only 60,000 dataset. I don't know why they did that, but if we download the database from the Python's library, we are gonna get the 60,000 dataset. This 240,000 dataset can still be used in Python, but not in C++. We are gonna extract this data into a folder that we are gonna give, but then it's gonna extract into these subfolders. Don't change the subfolders because the Libtorch, then this time both Python and C++, they have hard-coded this this path based on the path that you give. Then the subpath is hard-coded. We are gonna see that the dataset is in big endian. We are gonna take a look. How can we check this? We are gonna read a config file. We are gonna use simpleini in C++ and argparse in Python. Then we are gonna create the dataset in Python and then the same dataset in C++. Let's go. So this is the official website for the dataset, and if you scroll down here, you can download the data here on this link. But as I said, this will download a dataset that has 240,000 images. They indicate here that there is a second version on this website, but this website, if we click, it asks for user password, so it's not available. But we can download from the PyTorch library. Let's take a look. Here I'm back to the project folder. Let's open VS Code here. I can close this now. Yes. So let's our downloader. Here, my virtual environment. I like to use this linter. So what we are gonna do is we are gonna download the data. We already installed Torch from the PyTorch using pip in the previous video. So from here we can just import the dataset modules, and we need this to transform the data. And here I'm passing a location that I'm gonna create here right now. Sorry, here. So, and here I'm saying that this data is gonna be training, but what we are really interested is in this option, download true. So it will download the data here. If we run this Python file, okay, you see that it downloaded from that HTTP site that we can't access from the browser. But now, why it's not updating here? So I needed to refresh here, and now we can see the data. As I mentioned, it creates these subfolders for us and downloads. These are the test sets. The test set is 10k, so 10,000 images for the test, and the train images are 60,000 images. And how we can interpret this image? First, the labels. We have to open as bytes. If we click here on the first one, you see that there is this option, little endian. We actually have to uncheck this because the data is on big endian. And what does this says? This, we are gonna look at the 4 bytes here, or 32 bits, and they indicate this number, 2049. This number is what they say magic number. This number indicates that this is the valid data set. It's like a reference, so we know that we downloaded the correct data set. Then the next 4 bytes or 32 bits, 60,000. This means that we have 60,000 images. This is the label, so we have 60,000 labels in this file. Then for each byte, now we only look at 8 bits. It's the label. So this says that the first image, the label is 5. So the digit for the first image is a 5. Then we have a 0, then we have a 4, then we have a 1, then we have a 9, and so on, up to 60,000 images until the end. For the images, click here, uncheck the little endian. Again, the first 4 is a magic number, so this indicates this is the image file. Then 60,000, so we have 60,000 images in this file. Then this other 4 indicates 28, so the images are 28 on the x-axis and another 28 on the y-axis, so pixels. So it's 28 by 28 pixels. 28 times 28 is 784. That means that the next, if we look here at the bottom, 112. So if we scroll 784, 781, 283, 84. So all these bits represent the first image. Then the next 784 byte represents the I think you understand. So if you go 784, it's one image, then the next 784 is another image, then the next 784 is another image, until we reach the end of the file. For the labels, for the test set, we also have, uncheck here, a magic number. Then we have 10,000 labels, these 4, and then each one is the label for the test. So it's a 7, it's a 2, it's a 1, it's a 0, and so on, so on. And for the image, the same thing. Uncheck here, magic number, 10,000 images, 28x, 28y, then 784. If we select 784, it's one image, then the next 784 is another image, and so on, so on. Okay, first of all, let's create a config file that we are gonna use to get some inputs from the user. So a section here. First of all, we need the file locations. So I'm giving the path where I put the files and the name of the files for the train and for the test set. I'm gonna create here my Python file first. I'm gonna read the config file, and I'm gonna read those parameters. So I'm gonna take a look at the section MNIST, and I'm gonna get the base directory. If it doesn't exist, use MNIST. Then I need to concatenate the train, because this is gonna be the location we are gonna save the data later. Then I get the train file name, and then I concatenate the base directory with the file name, and here I concatenate with the label. And for our neural networks, we are gonna pass some parameters too. Let me already give them here. We need the number of generations, the maximum items, maximum image that we are gonna use in this train. We can change this later. If we are gonna save the image or not, so this will be a 0 or 1. This alpha is used in the neural network, so we can add mutations to the neural network. And this would be the hidden layer size. So you see that our network is gonna have one hidden layer, and this is the size of the hidden layer. This will affect our accuracy in the end, but we are gonna manage this later. For the C++, so first we need to include our simpleini in the project. So we need to indicate that we need to include the simpleini. We do that in the settings for the C++. Include, add an item. So I'm gonna copy here. We need this folder here for the simpleini. Let me put in the workspace. All right, let me bookmark this. Not here. This the bookmark. Let me bookmark this. Okay. So now it detects the header file in here. So first we initiate the simpleini. We load the config ini file. We check if it opened correctly. Then we get the data almost the same as the Python code here. So we get the base dir from the MNIST. So here, this MNIST is this one. Then what is the variable that we need? And we concatenate the same thing as the Python. So this will be where we are going to save the train data. This is where we are going to read the train file. And this is the train label. And to get the parameters for our neural network, so this is the Python one. And this is the C++ one. So if we use just get value, it's gonna get a string, but here we can get long doubles or booleans using these special functions. In Python, we also have a way to get directly numbers. So we use here get int, get boolean, and get float. Now let's check if we are reading the data correctly. We can just run this, and here all the values that are from the config.ini file. For C++, we are gonna do something. I'm gonna use this little macro here to print both the name of the variable and the value. This way we can easily print all the variables like this using that macro. And we need to return success. To compile on C++, I'm gonna use a CMake file. So I'm using .22.1. I cannot test before that. Probably you'll be able to do it with the 3.14, but I'm not gonna test this. I'm not sure if it's gonna work or not, so I'm just gonna say that it's the 3.22. We can give it a name. I like to include the GNU install directories. So we need here to include that directory. So I'm gonna just take from here. Add an executable. The config.ini, we need to copy it into two locations. The first one is where our build folder is gonna be. We do it using this. The current binary dir is gonna give us the build folder. And if we decide to install, then we need to put it in the same location as our binary file. And our executable, we also need to tell it that it's an installable executable, like this. So we can run the cmake configure, it's gonna ask which compiler we want to use. If you have Clang, it's gonna show here Clang. I don't have, so let's use this guy. And let's create a debug. Here we are gonna see that it copied here the config ini. So what happened is, if we make any change here, for example, if we just want 100 images for now, it's gonna reconfigure and it's gonna save here in the build there the change. And why is that important? This is important if we want to debug this file. So if we click here and we click on debug, so that error was because when I created this folder, I put ini, for some reason the I was capital I. So when I change here back to lowercase, now I can just compile here and run the debug. And then it's gonna read here the location that I'm running this debug. The location that I run this debug is this one. So the config ini has to be in the same location because I just put here the relative path. If I had put here like a full path, probably it won't be an error, but because I just put a relative path, then the config ini has to be copied here, and I use this cmake to copy the file here in the debug folder. And once we read the data, it's gonna print all the values here, the same as we did with the Python code. Now we need to start reading our data set. So I'm gonna create here a new folder, and I'm gonna put here an image class, and this image class is gonna have the number of rows, number of calls, so x and y, number of pixels. What is the label? So we are gonna read from the label file, right? If it's a 7 or a 3. The bytes for that pixel, so the 784 bytes. And I'm gonna give it an ID. It's just a sequence number, so we know which which image inside the image file that we are reading from. If it's the first one, the second, etc. And we are gonna need another class that's gonna contain all the images. So this is gonna get the file name, so one of this file, and the full path of the file. The label, so the other file, so one is the image file, the other is the label. So the dataset contains both image and label. What is the magic number for the image, and what is the magic number for the label? So from we import the data set, and we know that these numbers are constant. They are not gonna change, so I'm gonna keep them here. And the idea is to get a data set passing the image and the label path that we concatenated here. And I wanna wanna have a function that's gonna read based on the max items that I pass in. If I want to read only 10 images at first, then I can change here the max item. Let's read just the first 10, just so we can take a look. And let's create this read. We are gonna pass in the max item, and we are gonna return a list of images. First, we are gonna read the file as binary. So we have to tell Python to read as binary. We just check if the file was open or not. And we're also gonna read the label file also as binary and check if it was success. And now we start to read the file. And we are gonna read byte per byte, but if we remember, the magic number is just the first bytes of the file, and we have to tell it that's a big endian. If we don't pass it, it's gonna read as little endian, and we are not gonna have the correct number. And in here, we check if the magic number is the same as the magic number that we passed in before. So we know that we are reading the correct file. If this number don't match, you will probably pass the wrong file. Then we know that the next 4 bytes are the number of items. So for this file, it's gonna be, for the train file, it's gonna be the 60,000, and for the test file, it's gonna be 10,000. And from the image, we also know that then we have another 4 bytes, how many rows each image. So this will be 28. And this, the number of calls, also has to be 28 for this file. Then we read the label file. And also we have a magic number for the label. And how many labels we are gonna read. And here, just a safe check if the image, number of items, the image is the same as label. So if we pass the 60,000, this one has to be 60,000 too. Then we are gonna get we are gonna loop through this number of items. We passed in the max items that we want, but I check if the passed number is larger than the actual number of items. So if someone comes here and put 1,000,000, then it's gonna clamp the data into just the number of items. If not, if I just pass 10, then this will be 10. So in a range of the number of items that we want to read, I'm gonna create an ID. So this ID is just gonna be 0, 1, 2, 3, whatever. Then we need to read this number of bytes. So rows and calls, this will be 784. So we are gonna read the image files this amount of pixels. And at the same time, we want to read from the label file just 1 byte. And this has to be big. Now we can create our image object. We pass the rows, labels, in the list of pixels. Then we append it into our list of images that we created here. This new image up to the maximum number of items. And then we close the file. Let's check if our read was success. So the length of the image is 10 because we pass in only 10 items, and the label of the fifth image has to be 9. Let's train label, open here. So big endian 5 0 4 1 9. Okay, so this is the 0 1 2 3 4. So the 4 index is label 4. So our parser is correct. Now in C++ we are gonna read the data. I'm gonna create here a couple more folders. This one is in the root of the project. So for the include, we need to create our classes. Our image is going to contain the information on each image, like the number of columns, rows, the label, the bytes for the pixels, and the ID on the database. This is H. And our data set is gonna be a vector of images. We are gonna save the file names for the label in the image, and we are gonna get the image magic number and the label magic number. Now in the source, we add now it's CPP. We include the header. We're gonna receive the number of columns and rows, the label, the pixels, and the ID. We save them to these variables. And for the pixels, we are gonna do a mem copy like this. So we allocate the memory for our pixels, and we copy the data that we receive into our own pixel. And we need the data set. Which the constructor is only receiving the names of the files and the magic numbers for now. To get rid of this message, we have to include our include folder in the workspace. Include, we can add like this, workspace folder include. Yeah, I forgot to add a subfolder here. and we're gonna add these files into the subfolder. The same here for the source. We move these files here. Now it recognizes the includes. In our main file here, we are gonna include the dataset. The magic numbers will be constant, so we use this macro. And we create our dataset object, passing in the path for the image in the magic numbers. And the same as in Python, I want to have a read function that we still need to create. So in the header for the dataset, we add the function, and then in the source, we are going to start reading the data. So first of all, we need to open the file as binary. To do that, we need to include a string. So this, we have to tell it that we need to open as binary file. And for the label, if the label for some reason doesn't open, if you pass in the wrong file, for example, we have to close the handle for the image, and we are gonna throw an error here. We get some variables to receive the data. So we want to read the size of magic, so 32 bits, into the magic key, and we are gonna force a cast for the bytes here. So we are reading bytes, and then we cast as bytes just to read the data, but it's gonna be a 32 integer. But reading like this is gonna read as little endian, so we need to swap the endian to big endian, and this is the function that does the swap on a 32 bit. So now we swap the endian, and now we should get the correct value. If the value that we read is not the same as the one that we passed, we are gonna close the files, and we are gonna throw this error just so the user knows. Then we read the number of items, so this will be our 60,000 for the train file or 10,000 for the test file. And then we read the number of rows and number of columns. Then we do the same for the label. So we read the magic number for the label. We check if the number is the same as the one that we passed. And then we check the number of items in the labels, the number of labels, and the two have to match. So we check here if the number of items or the number of images is the same as the number of labels. So if we pass the file that is 60,000, then the labels has to be 60,000 too. And here we check for the maximum number of items that we want to read. So we don't want to read more than what the file has. So we guard here. And now we are gonna read the file. So I'm gonna give here some variables to read the data for each of the image. I'm gonna loop through the number of items. At the end, we have to remember to delete this allocated memory here and close the files. So while reading the data, we are gonna read the number of columns times number of rows, so 784 into this array of pixels. We are gonna read from the label 1 byte for each label and save it into this variable. And we are gonna create the image. When we create the image here, so let me put it on the side. So we are passing in the pixels that we read from the file, and then we copy it into our own image, because the next loop we are going to reuse this pixel. We only delete after the loop, so here we copy. But in here we need to include C-string. Now we don't have any error anymore. But then we want to save this into our vector. The problem is it's gonna leak memory if we just leave it like this. So to not leak memory, we need a copy constructor, and this copy constructor is gonna work like this. It's gonna receive another image and then copy the bytes from the other into our pixel. Copy all of the data into each of the variables, but these are integers, right? Only here we need to do this memory copy. If not, when we, where is it? When we push to the vector, this image is gonna get out of scope and will be deleted. But when we push to the vector does a copy, and then we need the copy constructor. And at the end, we also need a destructor, because we allocated memory or in the regular constructor or in the copy constructor. We need to delete the memory, and the destructor in the header too. Okay. Now if we go back to the C++, our read should success. I want to check if what I passed was correct. So the same as in Python, I want to get the length of the dataset and what is the label from the index 4. So I'm going to create these functions. Here in the header, and these are simple functions. So to get the length, I just get the length of our vector, the size of our vector. And to get the label, I go to our vector at the passed index and I get the label. Now we need to compile this in our CMake. We need to add our include folder. I'm gonna add here. And I'm gonna make this as a static library. So I'm gonna compile the dataset and the image into a library, and I'm gonna link it into our executable. If we build so if we run this, it failed to open image. Probably I didn't pass the correct path. Yeah, I need to pass the full path here. So let me just copy the full path here. It's gonna reconfigure. I need to install to copy the new config file, and there you go. With the correct path, it reads 10 because we pass here 10, and the fifth, right? Because it starts from 0, so the fifth it's 9, the same as we had in our Python code here. Now that we can read the dataset, what if we wanted to see the actual images as PNG files, the actual image, so we can open on our editor here? So first in Python, I'm gonna check that if in our config file, if we set the image to a Boolean value, true value, I'm gonna save as PNG file. In our dataset class for the Python code, basically, I'm just gonna loop through all the images and save individual images. Then in our image, we import the pillow, and we save each image individually like this. We get the save directory. I'm gonna concatenate with the index that we received. If the image is the 0, 1, 2, 3 in the database, what is the label, the actual number, and a PNG file. But here from bytes, this mode just tells that it's a black and white color image. There are other modes that you can read in the documentation. Here I pass the size of the image in rows and columns, and here the bytes. Let's see if it works. We change here to 1. We go back here and we run this data. It doesn't, I didn't create the folder. We need to create the folder here inside the raw. I'm gonna create the train folder. Let's run again. So now if I open here, refresh. Okay, after refresh, then our first image is a 5. There you go, we have the 5. A 0, a 4, 1, and so on and so on. I'm gonna create here the test folder already, because we're gonna need it later. And I'm not only gonna save as PNG, but I also want to see as a CSV file in a table format. So to save as CSV, I'm gonna pass here also the same save directory and the file name that I wanna save. The dataset class, I'm just gonna loop through all the images and save individual in the save directory. Here it's gonna be save file, right? I'm passing this save file name, not just the directory. Then in the image, first I'm gonna check if the ID is 0, because if it's 0, I want to create like a new file. If the file exists, this is gonna clear the file and then start writing. This A is for append, so if it's not the first one, it's just gonna append into this file. And I wanna write the first column, the label, so it's gonna be 504, and then I'm gonna join. First I'm mapping all these pixels as strings. Then I'm gonna use a list and join them, this list with commas, and then write a new line at the end. So we can already run this. Now it created here the CSV file. We see here the first is the label 504, and the rest are the images. There you go. We have here 0 is black and 255 is pure white. Let me see if I cannot find any 255 now, but it goes from 0 to 255, where 255 is white. Let's open the C++. Same thing. If the user put 1 in the save image, we want to save all the PNG files. let me delete this so we get new ones. And I'm gonna delete the CSV2. Okay, so in our dataset class, include dataset. I want a save function. Then in our source, our save function is basically gonna loop through all the images and calling the save as PNG for each image. But this has to be a reference. And then in our image, we save as PNG. Here we are gonna need our OpenCV. We need to pass the correct path here. Which dependency Linux, it's gonna be here up to this OpenCV4. So in our include, we include up to the OpenCV4. And this is the function. So we create an OpenCV matrix with this size, rows and columns. This is just an 8-bit for one color, and these are the pixels. And we are going to receive the location. This should be save file. No, yeah, this is just the path, so it's going to be the up here to the raw and then up to the train actually. And we are going to concatenate the ID on the database and the label, save as PNG, and then we write the image here. To compile this, we have to tell CMake where is our OpenCV, that we need the OpenCV package. So I do this like this, but it's gonna complain that because we didn't pass the OpenCV there. How do we do that? We go to our extension. In the config for the workspace, here in the config arguments, we are gonna pass the variable and the path for the OpenCV CMake. In our dependency Linux, OpenCV, it's inside lib. Usually people put in the share, but OpenCV decided to put in the lib. Then CMake, OpenCV4, and then we have the config file. So here we do OK. Our JSON becomes like this. We have the config here. And now if we select the debug again, it found the OpenCV. But then our library that we created, we need to target it with the OpenCV libraries. Let me just show a message here so you can see. here are the libraries that we compiled. We only compiled these ones. If you already have OpenCV in your system, you might get more, but on our first video we compiled this, and we only compiled those that we need. Now if we build, if we try to run this now in our binary, install dir binary, if we try to run this now, it's going to complain that we don't have the shared libraries. So we need to add them into our LD variable. So this path here, we need to export the LD library path, paste, and now if we run, there you go, we get this. The other option would be to put this into our system, or maybe if you, our system, I mean in your system, in the user.lib folder, or maybe in your local.lib folder, or maybe if you have mapped in your home folder, maybe I usually do this. I create a .local in a lib folder and I put them there. So then it's only for my user and I don't mess with the system. Or maybe you installed everything on your system, then you'll be fine. For this project, I prefer just to export the LD library path. Okay. And after we run this, now we got our images back. Now they were created by C++. And let me close all here. Let's save as CSV2. I want to have a function that saves as CSV. Here, but this is the file name. For the data set, it's just a loop, and here is by reference, so we loop through all the images and save them here. It's going to be the file name, so directly into the CSV file. For each image, we are gonna save its file name, and if the ID is 0, we are gonna open a new file. If the ID is not 0, we are gonna append to the existing file. I need to include the upstream here. And the file is gonna be first the label, then for each of the pixels, I have to convert them to unsigned char, as we created as char, so we can read the data, but I need to convert as unsigned char. If not, we are gonna get negative values. So to not get the negative values, we convert them to unsigned char before we write into the file, and we add a new line and then we close the file. Okay, we can compile again. Here we don't have any CSV file. If I run this again and refresh, there you go. Same thing, zeros for black color, and up to 255 it's gonna be white color, anything between a grayscale. If you see negative values, remember to convert to unsigned when you save them into the file. I'm here on my Windows, and I'm gonna show you some changes that we need to do. First, in the config ini, the base there needs to be a Windows path, like the drive. So then, changing the config ini, the Python script already works. Here the same thing, 10, because we have 10 items, and the label for index 4 is 9. For C++, we don't need to make any changes in the CMake list, but here in the settings, you can either go to the settings or you can just change in the JSON file. So instead of the dependency Linux, we change to dependency win, where you install your dependencies. For the OpenCV, we just need to put up to the include folder. We don't need the OpenCV4 that we have on Linux. This is the same, and to avoid problems here with the standard libraries, we need to add all these includes. Here will depend on the Visual Studio version that you have, but the others, and also here the Visual Studio, and here is dependent on the Windows that you have. It might change too. So if you want to look at this, open Visual Studio. You can do it by selecting here the Visual Studio. Also the OpenCV dir. Also it's just here where you have the config CMake file. Wherever you put your config CMake file, you put it here. On Linux, you see that we go deeper in the folder structure, but on Windows it's just the OpenCV folder. Okay, once we have the build files ready, we can go to our project, our build win, or whatever you configured your CMake. Let me show you again. It's this. The default is just build. I like to put win exactly because sometimes I compile both Linux and Windows. So you go to the win, and the solution file, you open your Visual Studio. You can open any project. Here in the include directories, edit. Here, all these folders are your include, so then you can just copy them here, and you won't have VS Code marking here that some library is missing. Okay. The only difference is that Visual Studio creates this subfolder here. If you want to continue with VS Code, you can delete this folder or just leave it there. It won't make any difference. Again, change the base dir to your correct Windows drive. The correct dependency folders for the OpenCV. They include the standard libraries for Windows, and the OpenCV dir is the config make file location. Okay. If you enjoyed this video, please leave a like, share it with your friends, and tell me what you think.